Today, I'm going to teach you practical cryptography by showing you how to encrypt your sensitive files using both symmetric and asymmetric encryption. And trust me, you don't need to know any mathematics behind cryptography to be able to do what I'm going to show you in today's video, because we are going to use a tool known as GnuPG to perform all of this. Without wasting much time, let's dive into the video. In this section, we are going to look at symmetric encryption, which is a type of encryption that utilizes a single key to perform both encryption and decryption. And to do all of that, we are going to use a tool known as GPG or GnuPG, which can be found by default on Linux or macOS. And if you are using Windows, you can go ahead and download it from Google. And to perform demonstration on symmetric encryption, I have created a file over here known as secret.txt. And we assume that this file is very sensitive and we need only to share with the people that are intended to see this particular information. And inside of this file, I have just written simple words. Let me open this file. You can see I've just written very sensitive information. We can assume that this information is very sensitive and only people, only selected individuals are required to see this particular information and not everyone else. And to perform encryption on this particular file, we are going to say GPG, and in front of it we are going to say -- symmetric, like this, symmetric, and in front of it we are going to provide the name of our file that we need to encrypt, and we are going to hit enter. And after that, it is going to prompt us to write the password or the passphrase. So I'm going to say ABC123. I'm just using a simple password, and over here as well I'm going to say ABC123, and I'm going to click OK. My mouse is stuck. I'm going to click OK like that, and it is warning me I'm using a wiki passphrase, but for the sake of the video I'm just going to use this one. I'm going to say take this one anyway. And after that, it is going to encrypt our file. But you may be asking why I'm using -- symmetric over here. I'm using -- symmetric over here because we need to tell GPG that we need to perform encryption on this file by using symmetric encryption. And if I say LOS, you can see a new file was created by the extension of GPG, which indicated that this file was perfectly encrypted. And if you don't believe me, if I try to say cat secret.txt.gpg and hit enter, you can see this file is completely gibberish, or it is a binary file, stuff like that. You cannot read anything from this particular file. So to perform decryption, we are going to use GPG again. We are going to say GPG, but in front of it, you are going to say -o, which stands for output, and we are going to put the name that we need the output file to have. So I'm going to say decrypt.txt like that, and in front of it, you are going to say -d, which stands for decryption, and in front of it, you are going to provide the name of the file that was encrypted, which is secret.txt.gpg like that. And if I hit enter, you can see it decrypted the file. And if I say LOS, you can see a new file was indeed created. So if I try to cut this file in order to see the content inside of it, we can say cut decrypt like that .txt, and if I hit enter, you can see it is similar information found inside of this file. But if you keep on thinking that this file is not the same as secret.txt, let me perform MD5 hash in order to see if their hash matches. So if I say MD5 sum like this, and if I put both of these files in front of this algorithm, and I say secret.txt as well, if I hit enter, you can see indeed their hashes match, which indicate that this file is similar to this file. But you might also notice one thing. When I perform GPG, the command did not prompt me to write my passphrase in order to decrypt that file. So that is because of a tool known as GPG-agent. This is a key management server for GPG agent. So when you encrypt your files, that GPG agent is going to store the passphrase inside of random access memory, or RAM, and whenever you perform a command, it just going to refer to that particular memory and it decrypt your file without prompting for passphrase. But if you need GPG-agent to forget about the passphrase, you are going to run the following command. You are going to say echo reload agent, and you are going to say pipe, then GPG-connect -agent like this, and if you hit enter, you can see it just say okay. Now if I try to run the GPG command again to decrypt the file, let me say decrypt1, and if I hit enter, you can see indeed it is prompting us to write the passphrase. So if I write the passphrase correctly and hit enter, you can see it is going to decrypt the file. Okay, so if I say LOS, you can see a new file was created. Now let me learn cat command again on this one in order to teach you another concept that is most important. So if I say cat secret.txt.gpg like that, you can see it is gibberish, you cannot read anything. But if you need to encrypt the file by using ASCII format or the text format, we are going to use the following command. We are going to say GPG as well, and then you are going to say -- symmetric. You can say -- symmetric in order to say we are going to use symmetric encryption, and in front of it or behind of it, you are going to use another tag known as AMA, like that, AMAR, like that, in order to specify that we need to encrypt by using the ASCII or text format. You will understand after I did this, and in front of it you are going to provide the file that we need to encrypt and hit enter. It is going to prompt us for passphrase. I'm going to say ABC123 again, and here I'm going to say again ABC123, and I'm going to say okay, and take this one anyway, and I'm going to say LOS. Now you can see the extension is completely different from this one. Now if I try to cut on this one, if I say cut, then secret.txt.asc or ASCII, you can see it encrypts the file, but it is going to provide also a good text to indicate that the file was indeed encrypted by using the GPG command. So guys, that is all about symmetric encryption. Now let us dive in to the asymmetric encryption that use two keys in order to perform encryption. Hopefully you have understood about symmetric encryption. Now let us go to the asymmetric encryption. See you there. In this section, we are going to look at asymmetric encryption, which is type of encryption that utilizes two keys for both encryption and decryption. And these two keys are public key and the private key. Public key is used for encrypting materials, and the private key is used for decrypting the material. So, in order to perform asymmetric encryption using GPG, we need to go through two stages. Stage 1 is to generate the keys, and stage 2 to encrypt the material. So how do we do that? The first stage is to generate the keys. We are going to use GPG --gen-key like that, and hit enter. It is prompting you to write your real name, but you can write whatever. I'm going to say mastertvt1 at like that, and hit enter. The email address, you can type whatever. I'm going to say mastertvt1 at, I'm just saying mastertvt1.com like that, no problem, and you can hit enter. Now it is asking I need to change anything, or I'm gonna use what I have typed over here. So I'm just going to say O for OK, like that, and hit enter, and the key is going to be generated. But that key, or those keys are being generated, are going to be guarded by the password. So we need to type the passphrase. I'm going to say ABC, as always, ABC123, and here I'm going to say ABC123 as well, ABC123, and I'm going to say OK, like that, and I'm taking this one anyway, and it is going to generate the keys, and we can wait for a few minutes, and the keys are already being generated. So how are you going to see your keys? And to do that, we're going to say GPG, then we're going to say --list -keys like this, and we're going to say --key ID in order to display the key ID, and we're going to say --key ID -format like this. And this key ID format can be into two forms, either long form or short form, but for my case I prefer to write it long form like that, and I'm going to hit enter. You can see I have multiple keys, but all of these are public keys, but the one that we have created is the last one over here, which expire in 2026, 27th of May, and you can see it was created on this date over here. So after that, we can see this one over here, this in front of this one over here is the key ID, And the key ID is important if someone needs to encrypt your files and send them to you so you can decrypt them. And you can see also my username is over here and my email is over here. So this is how we list the public key that we needed to share with someone else. And to list the private keys, we are going to say GPG like that, then dash dash list but dash secret like this dot keys, secret dash keys like this, and we are going to say dash dash key ID dash format, and we are going to say long, or we can say short, whatever, like that. It is going to list all of the private keys, and my private key over here, this one must be guarded by you, and do not share this with anyone. I'm sharing this with you guys on my YouTube channel because I don't care about this key. I'm just using this key in order to teach you about asymmetric encryption. And you can see over here the key ID are similar. Okay? Yeah. Sorry guys, I got a little bit of technical difficulties because someone walked in the room, and I cannot record if there is someone else in the room. But nevertheless, let's continue. So here, what we are going to do in order to encrypt by using asymmetric, we need to send this key ID to the sender of the message who need to send us a message. And as I showed you before, we actually uploaded our key to the PGP server by using the command GPG -key server, and then we send the key to the public key server so that other people can download our key, our public key, and encrypt the message and send that message to us. But for our case, in my scenario that I have created, I'm going to use Kali machine as the sender of the message, and the Kali machine is going to send us a message, and you are going to decrypt that particular message. So what we are going to do, we need to copy this key over here, and we assume that we send that key either by this key ID by using the email, or by sharing our username over here with the user from the Kali machine. So what I'm going to do here, I've run this command GPG -key server pgp.myt --receive, and then I pasted the key ID of my machine over here so that Kali machine can download the public key into their own machine, and put that key into something called a key ring. And if as you can see over here, it is imported into their key ring. And if we need to see that public key inside of the key ring, we are going to use the same command GPG -list -keys like this. And if we hit enter, you can see indeed this key was added to the key ring of the Kali machine. So what we are going to do here, we need to encrypt a message. Let us create a simple file that we need to encrypt. We are going to say echo, and I'm going to say this is very, like this is a very sensitive information, like this. And you are going to redirect that into a file known as, let us say, secret, or let us call it private.txt, like this, and you are going to hit enter. If we say ls, you can see the file is over here. So to encrypt by using asymmetric encryption, we are going to say GPG, and then we are going to say -encrypt. Remember, -encrypt, but before we write -encrypt or -e like this, we need to use one thing. We need to specify the ARMA so that we can encrypt by using the ASCII format, and then we are going to say -encrypt. I like to use the wrong format, like this, -encrypt, and in front of that we are going to say -r. -r meaning we mean recipient. So recipient is us who send that key to the public key server. So here after R, you need to put the key ID of the sender, of the receiver who is going to receive this message, or we are going to put the key ID of the public key that we needed to use in order to encrypt this message. So we are going to say Ctrl+Shift+V because I have already copied this key ID. So after doing that, you are going to in front of it, you are going to specify the name of the file that you need to perform asymmetric encryption on. So you are going to say private.txt like this, and you are going to hit enter. So here you can see a lot of stuff over here. It says that it is not certain that key belongs to the person named in the user ID. If you really know what you are doing, you may answer the next question with yes. So Here we are going to say yes because we are certain we have downloaded the key by using this key ID over here. So we are going to say yes, and we are going to hit enter. Now if we say LOS, we can see the file was indeed encrypted by using asymmetric encryption. And if we run cat on that file, we say private like this .asc, we are going to see this particular message. Over here you can see this file was indeed encrypted like that. So in order for decrypting this file, we need to send this file to the user or to the receiver that is going to receive this particular file. How do we do that? And for that case, I have created a scenario by using a tool known as SCP, or secure copying, which utilizes SSH protocol. So what we are going to do, we are going to say SSH like this, and then in front of it we are going to say we need to download that file from Kali machine. So what we are going to do after not SSH, we are going to say SCP like this, and in front of it we are going to put the address of the Kali machine, because we are downloading the file from Kali machine into our own computer. So we are going to say SCP like this, and after that we are going to put the address of the Kali machine over here. We are going to say Kali because I know the username of that machine at, and then we need the IP address of the Kali machine. So we are going to say ifconfig like this, and then we are going to say grep -i, then I'm going to grep the inet only like that. You can see there is inet 6 over here, which is the IPv6, but in our case we need this one over here. So I'm gonna copy the selection, and I'm gonna paste it on my Parrot OS over here, Ctrl+Shift+V, and after that we need to put this semicolon, and we need to specify the directory that we are going to download this particular file. And if we come over here, we can see the directory on a Kali machine is tmp, or temporary GPG. So I'm gonna say /tmp/gpg, and the name of the file for that case we know it is private.txt.asc like that, and we need to copy that file, to download that file into our current working directory. But for my case I'm going to put it inside of the tmp directory, because for temporary reason like that, I'm going to say to tmp and rename that file. Or you cannot rename that file, you can just put it as it is. And I'm going to hit enter like that, and we need to specify the password for Kali, which is Kali as well. If I hit enter, you can see I have downloaded this file successfully. And if I cd to the tmp directory, if I LOS over here, you can see the file was indeed downloaded over here. And if I say cut on that particular file, private like that, you can see the file was indeed encrypted like this. So in order to decrypt this file, I need to use my own private key. Okay, I need to use my own private key, and for this case I'm going to say GPG -- then I'm gonna say decrypt, or -d or -decrypt like this, and in front of it I'm gonna put the name of this particular file, private.txt.asc. but I forgot one thing. I need to provide the output, the name of the output file, which is with the -o flag, and in front of it I'm gonna say I need just to be renamed like private.txt, no big deal like that, and I'm gonna hit enter, and it is going to ask me to provide my passphrase. If you remember, I said it is ABC123, enter like that. And if I say LOS, you can see the file was indeed decrypted by using asymmetric encryption. And if I say cut on that particular file, private.txt, if I hit enter, you can see indeed the file was completely decrypted. And that marks the end of our video today. And thank you for all of you who have watched up to this session. And you can see I have a little bit of trouble speaking, because video creation is something new to me, and I will make sure that I improve after every video. So just subscribe, and we'll see in future how are we doing on this YouTube channel. This is Master TVT. See you on the next video. Goodbye.